Hello, now we'll see the SI units with respect to the second part in this session. A millimeter is equal to 0.001 meter. This is one example which is given for you all to understand. Just we'll go through this. You see this millimeter, that is 1 millimeter is given as 0.001 meter. That means millimeter is converted to meter. Okay, so this 0.001 can also be written as 10 to the power of minus 3. Okay, so 1 meter is given as, for here we should use small letter m itself, but for convenience I am using the capital letter M. 1 meter is equal to 1000 mm. This is known to us. 1 meter is equal to 1000 mm. So 1 mm is equal to how many meters? So you are converting the smaller unit, that is 1 mm is a smaller unit, which should be converted to higher unit as meter. 1 mm is equal to how many meters? So how to obtain this? You need to cross multiply. 1 into 1 divided by 1000 will be given. So that will be given as 1 by 1000. So how to write this 1 by 1000? I can write it as 0.001, or I can write this as 10 to the power of minus 3, or I can write it as 1 by 10 to the power of 3. So in different forms I can write this 1 by 1000. So always remember this particular formula form. The smaller units, when it has to be converted to higher units. So in this example, the smaller unit is 1 mm. When the mm is converted to meter, millimeter is converted to meter, smaller unit is converted to higher unit, the factor what you get is always the dividing factor. So here in this example, the dividing factor what we got is 10 to the power of minus 3. Same way, another example. So by this, the previous example, we got 1 mm is equal to 0.001 meter. So considering that 1 mm is equal to 0.001 meter, you are converting now the higher unit into a smaller unit. That is 1 meter is equal to how many millimeters? So now how to obtain? Again cross multiply. 1 into 1 divided by 0.001. 1 into 1 divided by 0.001. How can I write this further? 1 divided by 0.001. Again it is further reduced to 1 divided by, I can write 0.001 as 10 to the power of minus 3. How can I write again this 10 to the power of minus 3 as like this form also I can write, that is 1 divided by 1 by 1000, or I can write it as 1 into, you are bringing these contents into the numerator. So it is 1, when it is brought, this part is brought to the numerators, it will be no more dividing here, it will be 1 into 1000 by 1. So 1000 will go to the numerator, in the denominator you will be having the 1. So 1 into 1000 divided by 1, that is nothing but equal to 1000, where I can write this 1000 as 1 followed by 3 zeros are present. So it is 10 to the power of 3. So when higher unit, so here in this example higher unit is 1 meter, when it is converted to smaller unit, that is to mm, you will be getting the multiplying factor, that is in this example it is 10 to the power of 3. So always remember, when higher unit is converted to smaller unit, we will be getting the multiplying factor. That means those respective factors, whatever you have got, either the dividing factors or multiplying factors, the respective action has to be taken over whatever numerical values you are going to get through your reports. Hope you all have understood this part. Next one, moving on to cell concentration. The unit of volume for expressing cell concentration in the SI system is the liter. So most probably we'll be we'll be dealing with these cells. Cell counts will be giving. So usually the cells which is present in either blood or CSF, it will be expressed in terms of cubic mm or mm cube, means the same, that is microliters. In terms of microliters it will be given, but when you're giving the report you have to convert your values to liters. Okay, so for example, here red cells, here conventional unit is 10 to the power of 6 per cubic mm. Cubic mm means microliter, where this microliter is converted to liter. So smaller unit is converted to higher unit, so you will be getting a particular factor, that is 1. So this respective factor has to be utilized for your numerical value whatever you have got at the end of your procedures, so that when final report is given it should be a converted value, or it should be a value with the SI unit. Okay, leukocytes, here again microliter it has been given. When it is converted to liter, along with 10 to the power of 9, the respective factor also you have to utilize. 0.001 is nothing but 1 by 1000, or it is 10 to the power of -3, or it is 1 by 10 to the power of 3. Okay, here is also a list of substances with the respective conventional units as well as SI units. So here you can make out one example I'll take up, that is albumin. Conventional unit is given as gram per deciliter. So what is the meaning of deciliter here? Deciliter means 10 liters. So this 10 liters has to be converted to liter now. That is with respect to SI unit. So deciliter is big or liter is big? It is the deciliter is big. Here it is 10 liters and here it is liters. When the higher unit, that is deciliter, is converted to liter, to smaller unit, you will be getting a conversion factor, that is a multiplying factor will be obtained. So you can make out it is just 10 or 10 to the power of 1, which indicates it is a multiplying factor. So here the list of examples whatever you are seeing, all these are the up to bilirubin, these are your multiplying factors. When you get the decimals, it indicates those are the dividing factors. Or 10 to the power of minus also indicates those are the dividing factors. So with respect to this column in the next slide, by using the respective conversion factors with respect to bilirubin and glucose, the examples are given. We'll see that. With respect to glucose, the value is obtained for deciliters, which should be converted to liter. So in the previous tabular column we see the particular conversion factor. This has to be multiplied for this. It should be multiplied 200 into 0.055, which will give 11.1 millimole per liter. Same way bilirubin also, the particular factor, conversion factor, has to be multiplied. Again here also we have some of the SI units in terms of, that is the units as well as the symbols. Liter means L, deciliter means DL, milliliter means ML, microliter means micro symbol as well as liter, nanoliter NL, picoliter PL, kilogram means kg, gram means G, milligram means mg, microgram means micro symbol as well as G. There are certain rules to follow when you are using this SI units. So some general rules. The symbol for a unit should not be followed by full stop. So we have seen in our previous slides the different symbols for the different SI units. So the symbols itself we won't use the respective names for those SI units. You are just using the symbols. So symbols, when you are putting forward, you have to take care those won't be followed by the full stop unless it is the end of the sentence. For example, it should not end up like this, ML. It is incorrect unless the sentence which is the end, if the sentence is getting ended up, then you can give the full stop, making up the total volume to 1000 ml. Like this, if it is the end of the sentence, you can give the full stop. Next rule is a single space should be left between the value and the unit. Between one unit to between the value, the numerical value and the unit, a single space should be left. You can't write like this 10 gram. Soon after the digit, you should not write the SI unit. You should give a single space and then you have to write the unit. Thank you.